Okay, so good day to everyone. By the way, I'm Engineer John Renel Capellanes and welcome to Jacob Engineering Video Tutorials. Okay, so ang subject natin ngayon is Geotechnical Engineering. Ito yung ating Module 2 Part 3. Okay, so continuation tayo sa Part 2. Okay, so Part 2, ang ginawa natin doon is nag-derive tayo ng mga 4 common formulas. Okay, dito, mag-sample problems tayo. Okay, gamitin na natin yung mga formulas na na-derive natin. Okay, so may 3 sample problems tayo dito. And let's start na. Okay, so sample problem 2.3. A saturated soil used to determine the shrinkage limit has initial volume V1 is equal to 20.2 cubic centimeter. Final volume V2 is equal to 14.3 cubic centimeter. Mass of wet soil M1 is equal to 34 grams and mass of dry soil M2 is equal to 24 grams. Okay, question A is determine the shrinkage limit. B is determine the shrinkage ratio. C is determine the specific gravity of solids. Okay, so ito yung ating solution. Unahin natin sa A. Okay, so kapag sinabi natin shrinkage limit, may dalawang formula tayo. Okay? Since may M1 tayo at M2, V1 at V2, gamitin natin yung itong formula. So shrinkage limit is equal to M1 minus M2 divided by M2 minus V1 minus V2 divided by M2 times the density of water. Okay, so therefore, given na to, okay na yan, M1, M2, V1, V2. Okay na yan. So, we can directly solve the shrinkage limit of site. Okay, so SL is equal to 34 minus 24 divided by 24 minus 20.2 minus 14.3 divided by 24 times the density of water or 1 grams per cc. Okay, by the way, the density of water, okay, ito yung common na ginagamit natin. So, 1,000, there are 1,000 kilogram in 1 cubic meter. Or, it can be in, the same lang to, no? Density of water, it can be 1 gram per cubic centimeter. Okay, so equal lang yan, class. Kung i-convert natin itong 1,000 kilogram per cubic into grams per cc, that is equivalent to 1. Okay, nakuha nyo ako? Okay, so therefore, solving the shrinkage limit, this will be equal to 0.1708. Okay, or in percent, it is 17.08%. And this will be our final answer on A. Okay? So, how about P? So, determine the shrinkage ratio. Okay? Alam natin ang shrinkage ratio is equal to M2 divided by the density of water times V2. Okay? So, M2 stands for the mass of dry soil. V2 stands for the volume of dry soil. Okay? So V2 meron tayo, M2 meron tayo. So, we can directly solve SR. So, SR is equal to 24 divided by 1 grams per cc times 14.3 cubic centimeter. Okay? By the way, explain ko lang yung unit nyo. Okay? So, in mass, that is in grams. Okay? Ito, in density, that is grams per cc or grams per cubic centimeter. Okay? Times the volume, that is in cubic centimeter. Okay, so cancel in grams, cancel in yung grams natin, cancel din yung cc natin. So therefore, no unit na naiwan. Okay, so therefore, the shrinkage ratio is unitless. Okay, so therefore, our answer will be 1.678. And this will be our final answer on on B. Okay, so how about C? So determine the specific gravity. Specific gravity is equal to 1 over SR minus SL divided by 100. Okay, take note natin, yung SL natin is kailangan naka-percent to. Okay, kasi nag-over 100 tayo. Okay? So, meron na tayong shrinkage ratio, ito yan. At meron na tayong shrinkage limit, 17.08%. So, we can directly solve GS. Okay, so solving that, okay, so GS is equal to 1 over 1.678 minus 17.08 divided by 100, and that is equal to 2.35. And this will be our final answer on C. Okay? So, next sample problems tayo. Okay, so sample problem 2.4. Okay? A clay is found to have a liquid limit of 75%, a plastic limit of 45%, and a shrinkage limit of 25%. If a sample of this soil has a total volume of 30 cubic centimeter at the liquid limit and a volume of 16.7 cubic centimeter at the shrinkage limit, determine the following. Okay, so determine the mass of dry soil. B is a mass of soil at the shrinkage limit. Okay, C is the shrinkage ratio. And D is determine the specific gravity of solids. Okay? So, ito yung ating solution. Kapag naka-encounter kayo ng ganitong problem, okay? Kailangan yung i-graph ito. Okay? Para hindi kayo malito. Okay? Or para ma-visualize natin siya. Okay? So, i-graph natin siya. Ito yung ating graphical, no? Okay, so, vertical line, this represent the volume of soil. Horizontal, this is the moisture content. Okay? And then, kapag sinabi nating shrinkage limit, okay, so therefore, this, ito yung direction ng drying. Okay? Ito yung direction ng drying natin. Okay? Ito yan. Okay? So, i-graph lang natin siya. Okay? So, at 75%, assume lang natin, nandito yan. Okay? At 75%, this is our liquid limit. Okay? And then, yung plastic limit natin is 45%. Okay? So, 75, 45 is nandito siya. Okay? So, therefore, this will be the plastic limit is 45%. At yung shrinkage limit natin of 25%. Okay, so saan yung na-locate yung shrinkage limit natin? Okay, so nandito yan. Okay, so it is equivalent to 25%. Okay, ulitin ko lang, kapag sinabi natin shrinkage limit, yung properties ng soil niya is saturated. Okay, which is composed ng water at composed ng solid particles. Okay, and then kapag sinabi natin at kapag na-meet na yung moisture content at shrinkage limit, okay, mamimit na yung minimum volume ng shrinkage. Okay? Di ba, okay, pag dito, okay, itong point na to hanggang dyan, yung volume niya is nagsishrink. Okay? Kapag nag-decrease yung volume, nagsishrink yung volume ng soil. Okay? Kapag umabot na siya at shrinkage limit, okay? And then, yung moisture content mo is further drying pa siya. So, yung volume of soil mo is talagang hindi na magbabago. Okay? Talagang yan na yung minimum natin. Okay? And dito sa problem is, if a sample of this soil has a total volume of 30 cubic centimeter at the liquid limit. Okay, so meaning that the volume, okay, at the liquid limit is equivalent to 30 cubic centimeter. Ito yan. Okay, at kailangan nating intindihin ito. Okay, so if a sample of this soil has a total volume of 30 cubic centimeter at the liquid limit, okay, so meaning class that yung sample natin is initially, yung volume niya is 30 cubic centimeter. Okay? Kapag sinabi nating yun yung initial volume ng soil natin, okay, doon natin matatagpuan, class, yung yung initial moisture content or the natural moisture content of the soil. Okay? Kasi nandito yan. Nandito yung ating volume ng V1. Okay? So therefore, class, that the natural moisture content of soil is equivalent to 75%. So therefore, this will be equal to moisture content 1. Okay? This will be represent the moisture content in natural state. Okay, gets nyo ka, class? And then, okay, sinabi din dito, and a volume of 16.78 cubic centimeter at the shrinkage limit. So, meaning, yung volume dito, class, okay, yung volume ng soil at shrinkage limit is 16.7 cc. Okay? And, we know that the volume shrinkage limit is the same in sa volume ng dry soil. So therefore, 'di ba ito yung ating volume ng dry soil. Ito yung ating volume ng dry soil, and that is equal to 16.7 cc also. Okay, gets niyo ako, class? Okay, so ang tanong dito, paano natin kunin si mass of dry soil or yung M2 natin? Okay, how to solve M2? Okay, so using this formula, class, okay, so shrinkage limit is equal to M1 minus M2 divided by M2 minus V1 minus V2 divided by M2 times density of water. Using this formula, okay, paano natin kunin yung M2 natin? Okay, so yung target natin dito, class, okay, is to solve M2. How to solve this one? How to solve this one, class? Okay, how to solve that one? Okay, so we have initial moisture content, okay, which is 75%. Okay, kapag sinabi natin moisture content, class, okay, kapag sinabi natin moisture content is equal to weight ng water divided by weight ng solids. Okay? And then, di ba yung M1 natin, class, ito yung ating mass ng soil at natural state. Okay? At natural state. Ito yun. Okay? Kapag sinabtract natin siya ng mass ng dry, ano yan? Ano ito? Okay? That is the mass of water initially. Gets your, class? That is the weight or the mass of water. Or it can be in terms into mass also. Okay? Or mass ng water divided by mass ng solids. Okay? So therefore, class, this is the mass of water initially. Okay? Divided by the mass of solids or mass ng dry. Okay? So ano yan, class? Okay? That is the moisture content. Since M1 yan, class. So therefore, M1 minus M2, okay, we can conclude, class, okay, we can conclude that MC1, okay, MC1 is equal to M1 minus M2 divided by M2. This is the initial moisture content kasi M1 yan, class. M1 yan. Okay, nakuha nyo ako? Okay? So therefore, class, by simplifying, so therefore, SL is equal to MC1 minus V1 minus V2 divided by M2 times the density of water. Okay, so we know that MC1 is 75% and shrinkage limit is equal to 25%. Okay, so meron na tayong initial volume which is 30 cubic centimeter. And the volume of dry soil is, ito yon, 16.7 cc. Okay, so using this equation, so we have only one unknown. Okay, so therefore, we can directly solve now M2 or the mass of dry soil. Okay, so using that formula, so therefore 0.25 is equal to 0.75 minus 30 minus 16.7 divided by M2 times density of water, which is equal to 1 gram per cc. Okay, so solving that, we have M2, or the mass of dry soil, is equal to 26.6 grams, and this will be our final answer. Okay, na-gets nyo ako, class? Okay, so B. Okay, so determine the mass of soil at the shrinkage limit. Okay? So, kapag sinabi nating mass of soil at shrinkage limit, alam naman natin kapag shrinkage limit, yung moisture content natin, it should not be equal to 0. Okay? So, therefore, if the moisture content is not equal to 0 or greater greater than 0, so therefore the mass of soil at shrinkage limit is not equal to mass of dry. Okay? Kasi dry lang is, ito, mass ng solids lang yan. Okay? So, how to compute mass ng soil at shrinkage limit? Okay? Yung pinade-determine dito, class, mass talaga ng soil. Okay? Yung water at ng solids. Okay? Paano natin kunin yan? Okay, alam naman natin, class, kapag sinabi natin shrinkage limit, moisture content lang talaga yan. At anong formula ng moisture content? Okay, that is, shrinkage limit is equal to mass of water at shrinkage limit divided by the mass of solids. Okay, so, ito yun. Okay, so how to compute mass of water at shrinkage limit? How to solve this? Okay? How to solve that one? It is simply, shrinkage limit is equal to mass ng shrinkage limit divided by mass ng dry divided by mass ng dry. Okay? Di ba, class? Yung mass, focus kayo dito, class. Focus kayo dito. Okay? Yan lang. Focus kayo dyan. So, mass ng shrinkage limit minus mass ng dry, that is the mass of water present at the shrinkage limit. Okay? That is the mass of water. Okay? And divided by the mass of solids or mass ng dry, that is represent, okay, itong term na yan, that is represent the moisture content. Okay? So, we have the shrinkage limit is 25%. So, therefore, yung M2 natin is solved na, which is equal to 26.6 grams. Okay, so therefore, shrinkage limit, yung equation natin, magkagaganito. So, 0.25 is equal to mass ng shrinkage, mass ng soil at shrinkage limit minus 26.6 divided by 26.6. So, mass ng soil at shrinkage limit is equal to 33.25 grams. And this will be our final answer on B. Okay, gets nyo ako? Okay, so how about C, class? The shrinkage ratio. Okay? Okay, so, i-arrange ko lang, class. Okay, C tayo. Okay, so shrinkage ratio, may formula tayo, no? Shrinkage ratio is equal to M2 divided by the rho of water times volume 2. Okay, so we have mass 2, class, which is 26.6, and V2 natin is equal to, ito yan, 16.7 cc. So therefore, shrinkage ratio is equal to 26.6 divided by 1 times 16.7. Okay, and shrinkage ratio is equivalent to 1.593. And this will be our final answer, class. Okay? And D, class, no? And D is the specific gravity of solids. Okay, so we know that GS is equal to 1 over SR minus SL divided by 100. Okay? So therefore, meron na tayong SR. Ito yung ating SR, class. Ang shrinkage limit, okay? Ang shrinkage limit is equivalent to 25%. Ito yan. Okay, so therefore, class, ito yung ating equation. So, GS is equal to 1 divided by 1 over 1.53 minus 25 divided by 100. Okay, so therefore, GS natin is equal to 2.65. Okay? Take note lang, class, no, may i-add ako dito, class, kung anong purpose ng graph. Okay? Ano pang yung another purpose ng graph, class. Okay? Kasi may mga problem, class, na pinadidetermine kung anong volume ng soil. Okay? At respective moisture content. Meaning, yung example lang, kapag yung pinadidetermine yung volume ng soil at this, example lang, 50%. Okay? May problem na ganyan, kas. Okay? So, using this graph, we can solve the volume of soil at 50% moisture content. Okay? Using this graph. Okay? Ito yung unique niya, class. Yung graphical method. Okay? Nakuha niyo ako, class? Okay? So, last problem tayo, no? Okay? So, sample problem 2.5. Okay? So, during the determination of the shrinkage limit of a sandy clay, the following laboratory was obtained. Okay? So, weight of wet soil plus dish is equal to 87.85 grams. Okay? Dry weight of soil plus dish is equal to 76.91 grams. Weight ng dish is equal to 52.7 grams. Okay? And then, class, yung volumetric determination soil path, okay? Yung volumetric determination of the soil path class is ginagamit ito to determine the volume of oven-dried soil. Okay, yun class. Okay, so weight of dish plus displaced mercury is equal to 430.8 grams and weight of dish is equal to 244.62 grams. Okay, so calculate the shrinkage limit assuming that GS is equal to 2.65. Okay? So dito, class, okay, ito class, ito yun. Okay? This is the shrinkage limit test. Okay? Nag-oven dry tayo dyan. Okay? Ito namang data na yan. Okay? Ginagamit ito, class, kapag pinadidetermine ginagamit yan to solve the volume of oven-dried soil. Okay, so una tayo, ito yung ating solution, class. Okay, so unahin natin yung mass weight ng wet soil, class. Okay, weight of soil. Okay, so M1, okay, ito yung ating initial mass, class. M1 is equal to 87.85 minus natin sa weight ng dish. Okay? Kasi yung 87.85 may dish ito. Okay? So, minus natin sa dish na yan. Okay? So, 87.85 minus 52.7 is equal to, okay, that is 35.15 grams. Okay? And then, yung mass ng oven-dried soil natin, class, M2, is equal to 76.91 minus 52.7. Okay, that is the dry weight of the soil, class. Okay, and that will be equal to 24.21 grams. Okay, so may M1 na tayo at M2. Okay, dito sa ulitin ko lang, class, no, dito sa volumetric determination of soil path, ginagawa lang talaga ito, class, to solve the oven-dried soil or V2. Okay, so ito yung concept niya, class, no. Ito, explain ko lang yung concept niya, class. Okay, dito, class, may isang container niya, class. Okay, malaking container niya, no. Okay. Okay, ito yung malaking container niyan. At then ito, class, is puno yan, class. Okay, puno yan ng mercury. Okay, puno ito ng mercury, class. Okay, mercury yan lahat. Okay, mercury yan lahat class. And then kapag class ito yung oven dried sample natin class. Okay, ito yung ating oven dried sample. Wala na yan dish class ha. Wala na yan dish class. Okay, kapag nilagay natin dyan class, anong mangyayari? Okay, ito full yan class. Okay, kapag nilagay natin yung sample natin class, yung oven dried sample natin at nandyan class. Okay, anong mangyayari? Okay, anong mangyayari ng mercury? Yung mercury is yellow class. Okay? Anong mangyayari class? There will be a displacement of mercury. Okay, there will be a displacement. Okay? Kasi puno yan. And then sinubmerge mo. So therefore, there will be displacement. Or in Bisaya class is may nausik. Okay? So, paano na-determine? Okay, yung tanong dito is paano na-determine yung volume ng soil pad using this condition. Okay, paano na-determine niya class? Okay, ito yung concept ng class, no? Yung volume na cover ng sample class sa loob ng container is equal to the volume of displaced ng mercury. Okay, ulitin ko class. Yung volume ng soil sample kapag nilagay natin yan. Okay, so volume ng soil sample class is equal to the volume displaced ng mercury. Okay? So, kapag malaman natin class, yung volume ng mercury na displaced class, okay? Therefore, madidetermine na natin yung volume ng oven dried soil natin or yung V2 natin. Okay, by the way class, yung pag-displace ng mercury class is may container yan. Okay? I-collect nila yan class. Okay, gamit ng dish. Okay, i-collect lahat nila yan class. Okay? Okay, and then ititimbang class. Okay, i-weight and then i-record yan. Okay, so ito yan. Okay, so therefore class, to solve V2, okay, okay, so V2 is equal to mass of mercury divided by the density of mercury. Okay? Okay, so mass of mercury class, that is the mass of mercury displaced. Okay? And then we know, dito siya nanggaling class. We know that density is equal to mass divided by volume. So volume is equal to mass divided by the density. Okay, kuha niyo ako. And then, simplify ko lang to. So, is equal to mass of mercury displaced divided by Gs, or the specific gravity of mercury, times the density of water. Because we have this formula class now, that Gs is equal to the density of solids divided by substance divided by the density of water. Okay, so therefore, this one class is equal to Gs times the density of water. Ito yan. Okay, nakuha ko. Okay, and we know that class, that the specific gravity of mercury is always 13.6. Okay, so we have how to compute the mass of mercury displaced. Okay, that is 430.8 grams minus the weight ng dish class. Okay, minus natin yung dish kasi yung 430.8 may dish yan class. Okay, so therefore 430.8 minus 244.62 divided by what is our Gs in mercury class, that is 13.6. Okay, since grams ito class, since grams yan, okay, yung gamitin natin is 1 grams per cc. Okay? And this will be equal to 13.69 cubic centimeter. Okay, so may V2 na tayo, class. Okay? May V2 na tayo. Okay, so, and then class, di ba may dalawang formula yan? Okay, so, yung M1 minus M2 divided by M2 minus B1 minus B2 over M2 times density of water. Okay? Dito sa formula class, wala tayong initial volume na given. Okay, so therefore, using that formula, we cannot solve the shrinkage limit. Okay? Pero may pangalawang formula class. Okay, which is yung formula na to. Okay, ito yung na-derive natin class. Shrinkage limit is equal to V2 divided by mass ng dry or M2 minus 1 over density of solids times the density of water. Okay? And then to solve that one class, we have V2 class that is equal to 13.6. Ito 'yon. Ito yung class, 13.6. Ito yung ating V2. Okay? Yung M2 natin class, ito 'yon. 24.21. Yung specific gravity na solids class, okay, gagamit tayo dito. Okay, gagamit natin yan. Okay, density of solids, gamitin natin si JS 2.65. Okay, so solving that one class, that will be equal to, okay, may error dito class, no? May error dito class. By the way, may error dyan. Hindi yan 13.6. Okay, okay, this will be 2.65 class. This will be 2.65. Okay? So therefore class, the shrinkage limit is equal to V2 13.69 divided by 24.21 minus 1 over, okay, what is the density of solids class? Density of solid particles. That is the specific gravity of solids times the density of water. Okay, so that is equal to 2.65 times the density of water is 1 gram per cc. Okay, ito yan class. And then times the density of water times 1 grams per cc. Okay? I-check ko lang sa calculus to check kung error lang dito. Okay, i-check kung yung answer class is 13.69 24.21 divided by minus 2.65. Okay? So that is equal to 0.1881. Okay? 0.1881. So it should be shrinkage limit is equal to 0.1881. Or in percent class, it will be equal to 18.81%. Okay? So this will be our final answer class. 18.81%. Okay? So walang error sa answer class. Ito lang, yung pag-input lang nakin, sa akin class. Okay? And that's it class, no? Okay, that's it. The end na tayo. Okay, so the end of part 3. Thank you for watching and good luck and God bless. Thank you all.